Hi, my name is Parker Bovée. I'm the Waste and Recycling Associate at Cleantech Group. I'm joined by Chris Wai of Sixone Labs, the CEO. And we're here to kind of discuss the logistics of Sixone Labs, what they're kind of focusing on, their technologies and their market approach. Chris, if you'd like to give kind of an introduction and generally kind of where the company's at today, that'd be very helpful.
Yeah, thank you. Thanks for the opportunity. Sixone, what we're building is a technology to recycle blended plastics. And what we take is an algorithmic approach to it. What we see is that plastics has a lot of impurities in there, and all these impurities are quite controlled. So the way to really recycle is to do a much more targeted, much more selective approach to that recycling. And our way to do that is, how do you control that feedstock on the front side, and how do you control it in a way where you can use the data, you can use the algorithms to be able to predict what a reaction will look like and the path that will take before you start doing that reaction. So that's really the IP that we have developed. We're focusing right now on the textiles industry. Textiles is notorious for the amount of chemicals that's used in there. And there's a lot of textile waste in general. So what we're looking to do and what we're building is a solution to be able to extract that plastics, the polyester, out of the clothing and be able to turn that back into new virgin materials.
So interesting. One of the things I gleaned from our initial conversations was your focus on textiles and plastics, generally, let's say polymers, just generally.
Yep.
And that recycling is kind of an interesting term because all plastic has impurities, kind of by definition. Can you kind of enlighten us, for some of us who maybe haven't had the chance to speak with you, what exactly are the scope of these impurities in plastics? How deep does it go, really?
Yeah, and at the broadest level, plastics, even virgin plastic that we see, the plastic that you see in clear water bottles, which would be, people would think is the most pure material out there, even that has additives to it. You have plasticizers, you have stabilizers to give it the functionality, the rigidity that we all need, right? And those ones are the more controlled types of additives. But when you talk about things like clothing, when you talk about things like textiles, there are a lot of different additives. We're talking dozens of different additives that are in there to give it the color, to give it the hand feel, to give it the functionality we all like. And there are on the order of 10,000 different types of additives that can go into any clothing that we wear. And there are dozens of them in every single piece. Now, the challenge with all these additives is that different manufacturers will be adding them differently. Even for the exact same piece of clothing, you can have from one piece to another different types of additives that's in there. And that's really the complexity of all the polymer waste that we have out there, is how do you understand those additives? How do you understand how to process it in the presence of all these additives? The last thing I will say is that in terms of recycling of plastics, of polymers, just the pure polymers, that's been known for decades. We've known how to do that even when we started creating the polymers themselves. But it's really the understanding of how do you handle those polymers when you have these additives, and especially the complex additives, when you have dozens of different ones in there. That's the part that's really not known, and that's what we are innovating on.
I understand. So elaborate a little bit further on your fit in the textile industry. Kind of what expertise have you brought into the textile industry from this kind of new vantage point? Maybe elaborate a bit more on your background there, if applicable.
Yeah, so I used to be in the textiles industry. I used to be on the manufacturing side. So I saw firsthand what a manufacturer really adds to all of these, all the clothing that we all wear. And from one batch to another, I would be able to understand, I would not be able to understand what is the exact chemical that is added in there. And that's just the nature of all of the manufacturing. That's really the secret sauce, the black box that manufacturers bring to the table. That's how they save their costs. That's how they control their supply, and so on. That adds complexity. That adds a lot of complexity once it gets to consumers like us. And that's where, with post-consumer material, you end up with that broad range of different material, different clothing that we just don't know what to do with. And that's why less than 1% of it does get recycled right now. It's just not something that traditional chemical recyclers and their processes have the ability to handle. So for us, we take a different vantage point. Our vantage point is really, if we don't know what is coming in, and we're not going to know what is exactly in this clothing, how do we best use a different method to be able to direct that to a way of processing? And our approach to that is really, we see this as that data problem.
Exactly.
We see this as the problem of how do you structure that data? How do you structure and have enough of that know-how to be able to link it to a way of processing?
The data is everywhere, and you guys are really putting it to work, basically.
Exactly.
Yeah.
The data, the algorithms on how to predict that reaction, that's really the key focus of Sixone.
So staying on textiles before we maybe move to some of the other applications, how have you found kind of industry partnerships? Who have been some of the kind of big names or the ways you've gone about kind of incorporating your technology, or how do you look to apply that outwardly?
Yeah, so there are a few different angles that we need to look at. From the feedstock side, there are collections companies that we have been able to work with. Some have more controlled feedstocks that we would be able to process. But at the end of the day, what we're looking to build is that materials database, that knowledge base. And for that, we have partnerships with national thrift stores, collections companies that already have that supply chain in place, that they are currently sending the material to developing countries. But that is not something that is sustainable. We need to figure out how to solve this problem in our backyard. So that's what we're building out. The other part of it, on the downstream side, we work with all your major brands that are out there. The brands are the ones that really have the motivation and incentive to push a product out. But in addition to that, it's being able to connect that entire value chain, that entire supply chain, and ensure that the material that we're producing, which is of virgin grade, is going to be compatible with all the downstream processes. And that is a development that needs to happen with different one of these manufacturers, because each manufacturer might have their different requirements, which then will require different conditions for that input material as well. So for us, that validation and that trust that the manufacturers put in our product is one of the critical aspects that we've been able to successfully demonstrate, whether it's with partners in Asia, but as well as partners in the Americas.
Yeah, excuse the optimism, but it seems like you guys could be kind of the connective tissue that links this whole textile recycling.
That's what we're aiming to do.
That's what it sounds like to me. Okay, so looking outwardly then, what are some other verticals that you're exploring or industries? What are some of the other applications beyond textile recycling?
Yeah, so thank you for asking that. And I mean, as we look at polymers as a class, and maybe I should talk about all the waste that we have. We have metals waste, and there are very good ways of handling metal waste. We have organics waste, and there are a lot of great innovators working on figuring out how to deal with all the organic waste that we have out there. It's really the polymer class as a whole that we don't really understand right now. We don't know what to do with that. And for us, textiles is that first industry, and that's because it's highly complex, it's highly uncontrolled in certain ways. But in addition to that, you have the same problem in terms of impurities, whether it's in the automotive industry, in the consumer plastics industry, in the consumer electronics industry. All of these industries not only use PET to some extent, but in addition to that, this approach of dealing with polymer impurities, that is something that exists in ABS materials, in polystyrene, and other plastics as well. So for us, it's how do you know and be able to map all the different impurities and be able to drive that to a solution that maybe another company has already developed the capabilities to process.
Yeah, would you almost say that Sixone is creating kind of a value add that hasn't existed in the marketplace before?
What we're working on and what we're building is that marketplace and be able to direct the waste to a process that can drive value out of it. That is the core value of our platform.
And would you say that you're open to partnership with other innovative recyclers who are looking to kind of get the purest possible or insights on how to make the purest possible recyclate?
Absolutely. Like in terms of where we come in is we see the data as the most important aspect. Once we understand how to map that data to a certain process, then we have the ability to direct that material to the best use possible. That's where we can come in and add value.
So where is Sixone today, and what does the future look like in terms of scaling?
So we have a pilot facility that we have developed, and we've been operating that for 2 years. This pilot facility allows us to recycle and produce multi-ton orders for customers. We're in the process of scaling up to the next stage, which is a demonstration facility. And what that really is to do is to demonstrate that our current process, having this algorithmic recycling, being able to link to our depolymerization process, that can be operated in a highly efficient, highly scalable manner. And what that allows us to do is then solve the problem of textile waste. And as we continue to build, it's how do you deal with all of the different mixes of post-consumer clothing that is out there.
What are some of the challenges you've run into so far with kind of that scaling process? It's been 2 years, or have to have been some.
Yeah, so it's been 2 years since we have operated our pilot facility. And I would say, in terms of scaling up to engineer a system that is new, that does think about a chemical processing approach that is fundamentally opposite from what the chemical industry operates in, I would say the biggest challenge that we run into is that we need to be able to break the mold in how engineering firms, EPC firms, are thinking about how to scale up. It's really about how do you tune a process for a certain feedstock material, and how do you get that broad range of processability based on what the feedstock that's coming in. It's a fundamental difference to what chemical processors think about, which is more about, I have a very controlled feedstock and I've tuned a process for that feedstock, and then I'll scale that up to massive scales. It doesn't work that same way when you're dealing with the broad range of waste that we have.
Absolutely. I think that just about wraps it up, but I think 2 things that I took away were breaking the mold and algorithmic recycling. Those are 2 ones that just fit together so perfectly, and I feel like describes the company so beautifully. So thank you for your time.
Yeah.
It's been a great conversation.
Thank you.